Hello everyone, it's January the 4th. Alright, we have an easy question today, but I am not planning to do another difficult one today. Yesterday was quite tough. Yeah, I'm just gonna do another medium. Today the acceptance rate is 62%. So it's not just an easy problem, it's like the easy problem. By the way, yesterday the difficult one, right? Just like adding a letter in front, adding some letters in front of a string to make it palindrome, the shortest palindrome. Now the best solution for that is KMP, and I went through the whole ordeal to understand KMP again. I think this is probably the third time that I have encountered KMP, and every single time I have to dug my head into some place, and then just stay there for a while, just try to understand KMP. KMP is such a good algorithm, so smart that it still troubles me to understand how people come up with it and how to reason with it. Like when I see it and I read it through the article, I really have to calm down and read through the article about KMP. I am able to understand it. But then, a month, 2 months later, I don't use KMP and I just forgot about KMP. But it's such a good algorithm. The basics is we need to create what I think the article of the solution says it's called a fails function, which actually I don't like how it sounds like. Basically, it's an array, right? So it's a pattern, right? We're given a string, and we will create a patterns array, which patterns I, the ith position, records the number of letters of the prefix, the proper prefix that is also the proper suffix, right? So that is the idea. So once you have that, right? Once you have the proper prefix and proper, so which means like if at a certain position the value is 3, that means in this string from start to this position, the first 3 characters is the same as the last 3 characters, right? And then this is used for string matching, like a long string and a short pattern try to match, and it'll create this array, this patterns array of the short string, and then we start matching from the large string. And if there is any mismatch, right? If there is any mismatch on the large string, then we know immediately, right? Because if we match a certain k length, right? We match a certain k length, and k plus 1 does not match. And then what we want to know is, okay, then the k plus 1's position in the original string, where does it match? Where can we match? So now this k length that match to the pattern, we can find in our array what is the prefix as also the suffix. Once we find that, we can jump forward, right? We can jump forward quite a lot. So we don't have to still do one by one matching, we can just jump forward. And this jumping forward helps a lot. So, yeah. All right, let's take a look at what I have today. Have I done this before? Oh, yeah. Last year. The complement of base 10 integers. If an integer is the integer you get when you flip all the 0 ones and all the ones and zeros to its binary representation. For example, 5. I remember this one. So basically, we're going to flip it, right? We're going to flip it and turn that into, and it's a positive, the same as this. Do we need to do, no, we don't need to do the math kind of stuff. I think this is just straightforward. We'll see. I mean, again, Python has its own rules of doing binary values. I'm pretty sure this is pretty straightforward. So we can just do, maybe we can do, hold on. There is an operator, which is this, right? So let's say 5. What is this? This is -6. Okay, so binary 5, right? And binary this. Apparently, so we need to mask it. So 2's complement plus 1. I think this is this is -1, all right? So what about this plus 1? This is the negative value of it. That shall be 0, 1, 0. 0, 1, 0. I don't know. What does this one do? What does this tilde do? Is it -1 and then flip? Okay, so how about if it's -1? So how about 6? 6 is 1, 1, 1. No, that's still not the one that we're looking for. That's 1, 0, 1. If we flip it, it's 0, 1, 0. Yeah, I don't know. Huh. Maybe we need to do this and then plus 1, like on the outside. Oh, and it's, nah, that's not gonna work. Yeah, what's the tilde mean? I forgot. Tilde. Bitwise operator. Complement, right? It takes 1 bit of brown and returns its complement. If it is 1, then 0, 0, and returns 1. 60, the complement is, so it returns its 2's complement, right? Hold up. It returns its 2's complement? Its complement is -61. Oh, I think it's a complement. It takes 1 bit, and if the operand is 1, it returns a 0. And if it's 0, it returns 1. Its complement is this, stored in 2's complement. Nah, I still, because there's a lot of things, because it handles a lot of things for you, which I don't like. Invert a complement, right? Result operated as 2's complement integer. So it's interpreted. So for integers, this is equivalent to this -1. Okay. For each individual bit. And the result is interpreted again as a 2's complement integer. So we flip everything and interpret it as a 2's complement. So this is equivalent to this -1. Because it's 2's complement minus x, right? Minus x is 2's complement plus 1, right? So we do minus 1. Is equivalent to this. So minus x minus 1. So we need to do this plus 1, right? So we do this plus 1 is minus 5, and then we do binary this. Yeah, it is minus 5, which is minus x, right? Should not do binary. We shall do this. Is that or? Or is it and? The mask. Oh, I forgot. I need to check my. Yeah, I have a two's complement. So I get a mask, and then we say this exclusive or mask, and then turn. Two's complement. Okay, let me see again. So what we're saying is 5 mask 1 2, and then tilde this. Bin this. No. Oh, that is 2, right? Hold on. What are we doing here? So I still don't know the tilde. What does this tilde mean? Tilde is inverse. Hold on, let me see. So we have is 5 is 101, right? And yeah, I heard that. An exclusive or with the mask. So when we exclusive the mask, we get 1 0, right? We get 1 0, and then we'll do the tilde, and then with the tilde, if we say it's gonna be 0 0 0 0 0, right? And then it would be 1 1 1 1 1 0 1, right? That's the tilde. So 1 0 1 reverse should be 0 1 0 0 1 0. Ah, yeah, screw this. Screw this. I think I'll just 5 exclusive or 1 left shift 2, right? So this one will give us 1 0 1 1 1 1. Why does it give us 1? Wait, what's this? 4. No, I think it's 3. Right? 1. Oh, my bad, my bad. That's the mask. We got the mask wrong. Shoot. That should be -1. Dang it. Hold on. So we don't need, okay, so we don't need to worry about the, all right. So it's not, yeah, okay. So just exclusive or, all right, something 1 left to shift something minus 1. I can just do binary number. So len binary number, right? Line binary minus 2. I was trying to see if I can use the tilde. I don't like tilde at all. I still don't understand what the tilde does. What does the tilde do? Like bitwise, what does the tilde do? How? I think it should be the same. What did I do previously? Make it so much faster. That was exactly the same thing. Len, bin, left shift. Yeah, I don't know. How's that any different? Do we have more test cases this time? $128. It's the same. Yeah, well. Alright. I still don't know. I'm gonna read it again. So, tilde. What do you do? The bits of the 2's complement representation of the integer are reversed, and the result interpreted again. So for integers, this is equivalent to minus x minus 1. So 2's complement is reverse, then plus 1. Right, so that's minus x, what equals to, say, inverse x plus 1. Then minus x minus 1. That means the inverse. Okay. So that is the inverse. But the inverse, so again, 5 is this, right? But binary, this 5 is minus x minus 1. So this is minus 6. Right? This is minus 6. But what I want is the inverse version, right? So if I think about the inverse, what's the inverse version? It should be 0, 1, 0, right? And then all the ones. That's the binary version. So if we say, basically we want to turn this value into its binary form. So what we need to do is this value, right? So it's going to be this value mask 1 left shift. Let's go 8 minus 1. So, and then we do the tilde again. Right? There we go. That's the 2's complement. 0, 1, 0. Yeah. Now we're talking. So that's the 2's complement. So this is the same as inverse this thing. right? Inverse this thing, which if we do 3, that's 0, 1, 0, right? So we're gonna do, okay, so we can do this. So this one shall work as well. So I'm gonna return n, and this is no, has to be len bin and -2, and then one left shift this -1. Yeah, I'm pretty sure I don't need this one. Pretty sure I'll use this one as well. Okay, so yep, this one is right. What's the difference? The difference is so we reverse it, right? So this is a reverse it, and then we reverse it exclusive OR with a mask. So this one will produce, what does this one produce? This one produce, basically this is the negative value, right? This is the negative value, and then we obtain its, still doesn't make sense to me. Hold on, do it again. This give me -3. What does this one give me? This is the mask, right? This is the mask. And this is a negative value, right? This is a negative value. So what we want is to obtain the 2's complement version of the negative value, which according to that we need a tilde again. So this is, what is this? Well, we have a negative value. We have a negative value, which is the inverse of 5, right? So we inverse it, and exclusive of the mask, and then we do its inverse. That obtains the 2's complement. The 2's complement of the inverse of this negative value. The 2's complement of, let me first submit this. 2's complement. Let's see if we can summarize this. So this is a 1, right? And this is slightly more complicated. Actually, let me do this. We need a mask, right? The mask is going to be 1 left shift something -1. And then this will be mask. Mask is this. And then we can say we're going to do this n, which is the reverse version, but we want its we want its binary version of this. So we're going to say binary version of this will be this. Exclusive or mask is its binary version, right? No, this is the binary version because that's the reverse, right? We reverse it, and then the reverse is correct, but it's interpreted as a two's complement. So this is just a negative value, right? So we want this negative values um, regular, right? And then I'm going to return this. And of course, the first one is easier to interpret, but okay. Yeah. So I'm going to do a little bit explanation of this. So we know that this is LeetCode 1009, I think. All right. So we know that this produces the inverse or reverse, whatever you call it. Inverse, the complement of n. That is, each bit in n is exclusive OR with 1. However, the result of this is interpreted as a two's complement, right? As a two's complement value, right? Thus, this itself is not the solution, right? It's not the solution. Hence, we need to produce the unsigned, right? To produce the unsigned binary representation of tilde n. And to do that, we use the formula, this exclusive OR mask, and then exclusive OR. Which this produces, right? This produces the unsigned binary representation of this, which is the answer. And I'm not sure if I explained it well, but yeah, but that's that. But of course, this is easier. We just do exclusive OR and then call it a day. The tilde. Yeah. I don't like tilde. I don't like how Python just manipulate this, right, for you. So make it actually difficult. All right. Battleship embargo. What battleship? I remember I wrote a battleship program. One of my first big program in C. Alright, given n by n matrix where each cell is a battleship X or empty, return the number of the battleships on board. Battleships can only be placed horizontally or vertically. In other words, they can only be made of the shape 1 plus k, yes, or k plus 1. K be any size, at least one horizontal vertical cell separates between two battleships. One horizontal or vertical cell separates two. So the board is this. What's the output? Right? To the number of battleships on board. Oh, count. We need to count the number of battleships. I thought you were trying to put battleships on it. Oh, that's a different story. Okay, so this is 2. All right. So we can scan row by row. Yeah, like we scan whenever we encounter. I think that was the logic I had in the past. Whenever we encounter an X, right, then we go horizontal or vertical until we find, right, if we find it, and then we go 4 directions, right? So we go horizontal first. So when we go horizontal, we go thus, right? And then if it's nothing, so we keep going on one direction, right? Until we exhaust. Now we go on the other direction until we exhaust, right? And if we have more than one, right? If we have more than one, that means that's a horizontal, and we shall turn everything back into dot, right? So we are here, then we go left. And every time if we encounter, we just dot it, right? And then once we're done, we come back, then we go right. Every time we encounter, we dot it. And then once we're done, we see how many we have. If I have more than one, then we don't check the vertical, because vertical is not going to be. But if it's only one, then we check the vertical, right? And then once we're done, we put this one into a dot. Yep. It doesn't seem too complicated. The runtime will be, I actually don't know the runtime. Alright, so what we're gonna do is, for mn, so LAN board 0. Yep. Because it's 1, so we'll have 0. Could you do it in one pass? And without modifying the values of the board. Huh. Could you do it in one pass? Let's do it first and then think about this. So I in range m, j in range n. Right? I'm gonna say if board ij is equal to x, right? And then we go horizontal. Then I'm gonna say for k in range and count, right? Count is 0. So for k in range, we're counting at j, so j plus 1 to n. If board ik is equal to x, board ik is equal to dot, and count plus equal 1, right? And then do the exact same thing, go the other direction. K from 0 to j, the same thing. Oh, actually not 0 to j. Oh, hold on. If this is this, and we do this, else break. And this has to be, oh my god. from j to -1, -1, right? If this, else, break. And then we say if count is larger than 1, result equals 0, right? If count is larger than 1, then rest plus equal 1, right? And we can continue. Right? Continue. Rest equal 1, then we set board I j or equal to dot. Right? If it's larger than 1, then we do this. And else then we try vertical, right? So this one vertical for k again in range, go up. How do we go up? Go up will be, it's actually j minus 1, just realized. So it'll be I minus 1, right? Minus 1, minus 1. If board k j is equal to this, we'll count 0. Oh, if it's this, in this case, if we encounter it, we'll always, rest plus equals 1. We always do it, right? And then the job is to eliminate. Then we don't need this. We just, if we encounter it, we always count as 1. And then we just do this, horizontal, right? And then vertical. It didn't really ask for how many are vertical, how many horizontal. So this, I'm going to say board kj equals to dot. All right, else break. And then for k, now I want to change. How about horizontal? We go, yeah, that's fine. How about y? Horizontal, we go y. Okay. Horizontal, we go y. And vertical, we go x. Okay. For x range. So this is going to be I plus 1 to m. If board x j is equal to x, board x j equals dot, else break. Right, so we go horizontal, then we go vertical. And so once we're done, board itself, turn this. Right, and then we just return rest. All right, let's take a look. 2, and this shall be 0. Board count Battleship. This is correct, but I did make changes, so we have to reconsider this after we pass. Yeah, I have confidence. This should be right. Yeah, this is right. So once an x is encountered, Oh, we can actually save it. Ah, that's why I use, oh my god. So we should say is horizontal, is hori shall be false. And then once it's done it, then is hori equals true. We need a flag, right? We need a flag. And then if it's hori, if is horizontal, then continue. We don't have to go vertical. So once an X is encountered, right, we check horizontal to turn all the other X's to dots. If the ship is not horizontal, we check vertical. Right, we check vertical. Encountered, we add one ship, and then we turn this current ship to dots. When we remove, then we remove the current. We remove this ship by checking horizontal first, and then vertical. This ensures that each encountered X only represents one ship. Actually, this one we should go in the first. Right, this one shall go first. And then rest plus equal 1. And then we check horizontal, then we check vertical. Okay. And I think this one will be a little bit faster because sometimes we don't have to check twice. And it's the same. Yeah, it's the same. It's the same. Alright, what's the runtime? And worst case scenario, for each cell, go right? And then we'll go down and back. Right, down, we stretch the entire thing. And then, now we don't go vertical. And then we go the entire thing. Jump here, we go the entire thing. Then we jump here. I suspect this is O(n) squared. That's what I think. It's O(n) squared. Yeah, I call it O(n) squared. That's why it's slow. It's a 126. 126 milliseconds. The 7% ranking. It's bad, but we can do better. We can do better. Well, it's not M. It's going to be MN. Alright, so the one thing we can do for sure is if the ship is horizontal, right? And then we already check. And then we go from the left to right. We go from left to right. So the first one we encounter, we only need to go down once. We don't have to go down. Yeah, this is not necessary. This is not necessary. Because we go scan from left to right. So every time we encounter will be the leftmost if it's horizontal. Right? Then we just check the entire thing. And then once it's good, right? Once it's good, then we can skip. Right? We can skip. And if we encounter vertical, we can also skip because two ships cannot cross each other, right? They cannot cross each other. Therefore, let's do this. Ij equals this, right? So while I is smaller than m, while j is smaller than n, check, right? If board ij is equals x, right? If board ij is x, then we set res plus equal 1, yes, right? So board ij is x, then res equal to 1. Then we need to decide if it's a horizontal shift or a vertical shift. Then we say check horizontal. Yes, we check horizontal. So is hard equal false. Then we say for y in j plus 1 to n, and if that only this, right? For this, if this is this, if this is not equal to this, then we break, right? So when we break out, then we're going to check. We say if y, because y is j plus 1, right? If y is larger equal to, it's not equal to, so it will hit j plus 1, right? You know what? It should be like this. Y from j to the end, right? So the first one will definitely check, right? The first one is equal to. So we go up again. So now y equals to j plus 1. Then it check. If it is, it keep going. If it's not, then it come out. Why do we do this? We can just simply check, right? We can just check horizontal. How do we check? If board I j plus 1 is equal to this, but we want to walk all the way down because that's how many we want to skip. So yeah, that makes sense. So we have to do this, right? So if it's equal to, then we keep going, and then it jumps out. It jumps out. So the first one, it jumps out. So we're going to count how many, right? So if y, hold on. Let me think again. If it is, then hold on. Let's do this. So y plus 1, right? And then if it's not, it will come back out. So we're gonna count how many. So y, when it come out, it will be the one that doesn't have, right? The one that doesn't have. The one that does not have. But what if it's vertical? If it's vertical, right? If we're talking about vertical, then hold on, let me think again. So we're scanning, right? We're scanning, and then from this we try to see how many more x's there are, and right, we want to see how many more x's there are. If there are more x's, then this ship is horizontal, right? This ship is horizontal. If it's horizontal ship, so we can jump to the next one and then keep checking. So we can count how many, the length of this horizontal ship. So what is the length of this horizontal ship? The length of horizontal ship is the first one that's not minus. So if y minus j is larger than 1, then it's a horizontal ship, right? So it's a horizontal ship. Then j can jump, right? J can jump to y plus 1. Okay, y is the empty, so it has to have, so j can jump forward, and then we keep going. So this is horizontal ship, right? Horizontal ship. If not, so when we encounter it, if not, but isn't it easy to check if it's a vertical, right? If I encounter this and we check above, right? If I check above, that is if I check above, that is an x. That means this was a part of the vertical, right? Part of the vertical. And we then can just jump to forward and we check horizontal. And if we encounter up as still, and then we encounter one, then how do we know the vertical ends? How do we know the vertical ends? Because I want to avoid checking vertical by itself, and then we have to go through those again. Let me think again. Think again. Okay, so we will have the first one. If it's a vertical ship, I will check up, that's an empty. So that is potentially either vertical or horizontal ship, right? So I add 1. So the first time I add 1 is if we encounter something, it's up and left, both are empty, right? If it's up and left, both are empty, that is the start of a ship. It could be either horizontal, it could be vertical, doesn't matter. So I add that already. And then we keep going left. And if it's not, that means no. And then we go. Oh, it should, wait. That is the case, right? If it's a ship, then its up and left must be empty. Like these are not ship because its up is not empty. This is not ship. If it's a horizontal, then it's, oh, that might be the case. So then we don't need any of this. So if this is this, then we check it. So if, right, if, so hold on. So three situations, right? Either I have an up and left, right? If we don't have an up, but we have a left, if we don't have a left, but we have an up, and we encounter, then that must be a ship. So I'm going to say so if we have an up, or if we don't have an up, That's fine. Now we have a left. So if I is smaller than 0, if I is equal to 0, or j is equal to 0. How should I do this? So it's if I is 0. Oh my god. How do I express this? If I is 0, right? If I is 0, that means there's no up. And to the left is either 0 or nothing. So I'm gonna hold on again. So if to the left is nothing or is empty, that's on the left side. Or up is nothing or empty. So this is 2. So we have 2 situations, right? So we have first is left and right. So for the left, either j is 0, right, or board ij minus 1 is equal to this, and I is 0, or board I minus 1j is equal to this, right? When this is, then we say rest plus equal 1, and then return rest. 0. I don't need this. I in range m, j in range n. The rest 0. Yep. And in this case, we drastically simplified it. Right? So I'm going to change this. So this one is the signature of since we scan the board left to right and top to bottom, we will always encounter the beginning of a ship, and the beginning is characterized by an X with its up with a cell to the top and left of X not being X. Thus, all we need to do is to count the number of the start of each ship, regardless of whether they are horizontal or vertical. And this one runs in OMN and a 1 pass. Let's see. Oh. Uh-oh. It's only slightly faster. So this one runs in, I thought we got wrong. On 8%. All right, what is the solution? But you cannot jump. That's 1 pass. I'm not changing anything. I mean, just every time we hit this, we have to check. Let's see. What's the smart solution? This is pretty smart, I think. Yeah, it's the same idea. It's exactly the same idea. First cell of the battleship. Top left cell. Yeah, exactly. That's the same idea. How is my solution so much slower? Right? What the hell? So this is the majority. What the heck? Yeah, that's exactly the same. Yeah, yeah. All right, that's fine. That's fine. We did find a good solution. It's just, maybe there are less test cases back then. All right, that'll be it. It took a while. I don't know. Today I'm a bit fuzzy. All right, see you guys tomorrow. Adios.